Download this code from codegive.com, link in the description below. OK, let's dive into the process of tracing errors in JUnit test cases. This is a crucial skill for any developer as it allows you to quickly identify the root cause of issues and maintain a healthy code base. Understanding JUnit failures and errors. Before we begin tracing, it's essential to understand the difference between a JUnit failure and an error. While they both indicate a problem, their meanings are distinct. Failure. A failure occurs when an assertion within a test method fails. This means the test ran without any exceptions, but the actual result didn't match the expected result. This is usually due to a logical problem in the code being tested or a problem with the test itself. Error. An error occurs when an unexpected exception is thrown during the test's execution. This indicates a problem in the code being tested that the test didn't anticipate, or an issue within the test itself, example a null pointer exception in the test code. Errors are often due to runtime problems like null pointer exceptions, indexoutofboundsexceptions, ioexceptions, or other exceptions that halt the test's intended flow. 2. Preparing for effective error tracing. 1. Read the error message carefully. This is the first and often most important step. JUnit provides error messages that pinpoint the failing assertion or the thrown exception, along with the line number where it occurred. Pay attention to the type of exception, example null pointer exception, assertion error. The message associated with the exception, example expected, love, but was, 5. The stack trace. To understand the test context before diving into the code, make sure you understand what the test is trying to achieve, what specific functionality is being tested, what inputs are used, what output is expected. Dependencies. Does the code under test rely on any other classes, services, or external resources? Are they correctly configured in your test environment? 3. Keep your tests small and focused. Well-designed tests should be small and test a single, specific aspect of the code. This makes it easier to isolate the source of an error. If a test is overly complex, refactor it into smaller, more focused tests. 4. Use meaningful test names. Give your tests descriptive names that clearly indicate what they are testing. This will help you quickly understand the purpose of a failing test. For example, test calculateria _valid input _returns correctoria is much better than test calculate area. 3. Tracing techniques, a step-by-step guide. Let's assume you have a JUnit test that is failing. Here's a systematic approach to tracing the error. Step 1. Analyze the error message and stack trace. Locate the failing test. The JUnit runner will clearly identify the test method that failed, example example.myclasstest.testSum method. Examine the exception type and message if it's an assertion error, the message will usually tell you what was expected and what the actual value was. For example, this means the assertion assert equals 3, actual value, failed, and actual value was 5. If it's a different exception, example null pointer exception. This indicates a null pointer exception occurred in the calculate something method of my class, called from line 22 of the test. Follow the stack trace. The stack trace shows the sequence of method calls that led to the exception. Start at the top, the exception itself, and work your way down. The lines that belong to your code are the most relevant. Ignore lines that refer to Java library classes or JUnit internals unless you suspect a problem there, which is rare. The line number in the stack trace is crucial, it tells you exactly where the exception occurred. Step 2, reproduce the error locally, debugging. 1. Set a breakpoint * place a breakpoint in your IDE, example IntelliJ IDEA, Eclipse, VS Code, on the line of code indicated by the stack trace, or on the line before it to inspect the values of variables before the potential exception. 2. Run the test in debug mode *. Most IDEs have a debug option when you run your tests. This will execute the test until it hits the breakpoint, allowing you to step through the code line by line. 3. Inspect variables * as you step through the code, examine the values of variables using your IDE's debugger. Pay close attention to * variables that are used in calculations or comparisons. * variables that are potential sources of null, if you're dealing with a null pointer exception. * variables that are used as indices into arrays or lists, if you're dealing with an index out of bounds exception. * input parameters to the method under test. 4. Step into / over methods *. Step into, F7 in IntelliJ, F5 in Eclipse, allows you to enter a method call and debug inside that method. Use this when you suspect the problem lies within a method that's being called. * step over, F8 in IntelliJ, F6 in Eclipse, executes the current line and moves to the next line in the current method. Use this when you don't need to debug the inner workings of a called method. Step 3, adding logging statements, if debugging is insufficient. Sometimes, debugging alone isn't enough, especially when dealing with complex logic or multi-threaded scenarios. In these cases, add temporary logging statements to your code to track the values of variables and the flow of execution. * Use a logging framework * instead of system.out.println, use a proper logging framework like SLF4J with logback or log4j2. This provides more control over logging levels, output destinations, and formatting. * Choose the right logging level *. Debug, detailed information useful for debugging. * Info, general information about the application's state. * Warn, potentially problematic situations that don't necessarily cause errors. * Error, errors that prevent the application from functioning correctly. Step 4, simplifying the test case, isolate the problem. If the initial test case is complex, try to simplify it to isolate the specific condition that causes the error. * Reduce input data * If the test uses a large data set, try using a smaller, simpler set. * Remove unnecessary assertions * If the test has multiple assertions, comment out some of them to see if the error still occurs. * Create a minimal reproducible example * The ultimate goal is to create the smallest possible test case that still exhibits the error. This will make it much easier to understand the root cause. Step 5, examining external dependencies. If the code under test relies on external dependencies, example databases, web services, verify that those dependencies are configured correctly and are functioning as expected. * Check configuration * Ensure that connection strings, API keys, and other configuration parameters are correct. * Mock external dependencies * Use mocking frameworks like Mockito or EasyMock to isolate the code under test from external dependencies. This allows you to control the behavior of the dependencies and simulate different scenarios. This is especially important for unit tests. Step 6, reviewing the code, code coverage. Once you've identified the area of code that's causing the problem, carefully review the code for * logical errors * incorrect calculations, flawed algorithms, incorrect conditional statements. * off by one errors * common in loops and array access. * resource leaks * failure to close files, connections, or other resources. Asterisk concurrency issues, asterisk race conditions, deadlocks, if you're dealing with multi-threaded code. Asterisk boundary conditions, asterisk test edge cases like empty lists, zero values, maximum values. 4. Example scenario with code. Let's illustrate with a simple example. Code to be tested, string calculator.java. JUnit test, string calculator test.java. Scenario, test @null input return 0 fails. If test @null input return 0 fails, you would get the following information from JUnit. Tracing the error asterisk. 1 error message asterisk. The error message clearly states expected 0 but was java.lang.nullpointerexception. This tells you that your assertion expected 0, but the add method threw a nullpointerexception. 2 stack trace asterisk. The stack trace points to string calculator test.java 40 and some JUnit internals. We need to focus on what's happening at line 40 of the test. Assert equals 0, calculator.add, null. The add, null, call is likely the culprit. 3 code review asterisk. Look at the add method. The problem is that when numbers is null, the numbers.split, call will throw a nullpointerexception. 4 solution asterisk. You need to handle the null input more carefully. Or even better, more concise and idiomatic. This works because the check numbers equals null numbers dot is empty, already covers the null case before the split call. V. Common pitfalls and best practices. Asterisk. Ignoring warnings asterisk. Pay attention to compiler warnings. They often indicate potential problems. Asterisk. Assuming errors are in the test asterisk. Don't always assume the problem is in the code being tested. Sometimes the test itself is flawed. Double check your assertions and test setup. Asterisk. Using magic numbers / strings asterisk. Avoid using hard-coded values in your tests. Use constants or variables to make the tests more readable and maintainable. Asterisk. Insufficient test coverage asterisk. Ensure that your tests cover all important aspects of the code, including boundary conditions and error handling. Use code coverage tools to measure how much of your code is being exercised by your tests. Asterisk. Over-reliance on integration tests asterisk. While integration tests are important, focus on writing thorough unit tests first. Unit tests are faster to run and easier to debug. Asterisk. Not cleaning up asterisk. When testing anything that interacts with a database or other external system, make sure to reset the state so other tests aren't affected. At before each and at after each are your friends. 6. Advanced techniques. Asterisk. Fuzz testing asterisk. Use fuzz testing techniques to automatically generate a wide range of inputs to your code, looking for unexpected behavior or crashes. Asterisk. Mutation testing asterisk. Use mutation testing tools to introduce small changes, mutations, to your code and verify that your tests are able to detect those changes. This helps you assess the quality of your tests. Asterisk. Static analysis tools asterisk. Use static analysis tools, example SonarQube, find bugs, to identify potential code defects before you even run your tests. These tools can detect null pointer difference, resource leaks, and other common programming errors. By following these steps and using the techniques described above, you'll be well equipped to trace and resolve errors in your JUnit test cases efficiently and effectively. Remember to be patient, methodical, and persistent, and you'll become a debugging master. Good luck.